Advanced Denim for more sustainable denim colors and effects. Almost 2 billion pairs of jeans are manufactured every year. No item of clothing is more popular. The starting material is cotton, which passes through numerous processing steps from the cotton field to the finished thread. In the textile factory, the raw cotton is fluffed up, cleaned, and the single fibers are pressed into loose strands before being spun into yarn. Since the gold digger era, the yarn for jeans has been dyed blue with indigo. With advanced denim, Chroma is now ushering in a more eco-friendly era of jeans production without indigo. Traditional dyeing with indigo requires the use of long production lines, some stretching to more than half a mile in length. These machines consume enormous amounts of water and energy. Moreover, when the color is changed, most batches create large amounts of cotton waste because of the need to dispose of all the fibers still inside the machine. After spinning, up to 4,500 cotton threads are simultaneously pre-wetted, degreased with chemicals, and cleaned in several preparation baths. Now the actual dyeing process begins, with an average of 10 dyeing vats. The yarn fibers are immersed in the first indigo dyeing box. Indigo in its natural agglomerated state is not soluble in water, and in this state cannot penetrate into the fiber material. The molecules have to be separated to make them water-soluble. This is done by reduction of the double-bonded oxygen. In this reduction process, the strong reducing agent sodium hydrosulfide causes the indigo to take up negative charges. The molecules repel each other, making the indigo soluble in water. In this process, indigo loses its blue color. It turns yellow. The dissolved and finely dispersed indigo molecules can now settle on the top layer of the cotton fiber. The yarn fibers are then exposed to atmospheric oxygen, which removes the negative charges from the indigo molecule, causing the oxygen groups to return to the original form. In other words, they are oxidized. The indigo molecules turn blue again. The dye is no longer water-soluble and adheres to the fiber. For intensive and uniform dyeing, the cotton has to pass through 6 to 15 consecutive dyeing vats because the fiber absorbs the indigo only very slowly. This process not only consumes vast amounts of energy, but also and above all, large quantities of water. The next step removes the chemicals previously added for cleaning and reduction, as well as the unbound indigo in several washing boxes. This produces large volumes of colored wastewater contaminated with sulfites, which adversely impact the aquatic ecosystem. The yarn fibers are now dried, and during the sizing process are coated with a film of starch to protect them during the stressful weaving process that follows. The conventional production process involves the use of about 15 to 20 immersion baths, strong reducing agents, and vast amounts of water. This results in a high energy demand, contaminated effluents, and, according to National Geographic magazine, an estimated water consumption of 11,000 liters for each pair of finished jeans. The groundbreaking technology of advanced denim, the new pad sizing ox process, provides savings of up to 92% water, 30% energy, and 87% cotton waste during dyeing and sizing, and generates absolutely no wastewater. Central to the new process is the more eco-friendly Chroma generation of concentrated liquid sulfur dyes. With a high affinity for cotton, just a single dyeing box and one sugar-based reducing agent are needed to obtain a medium color intensity. The next step is a combined sizing and oxidation box, in which the dye is fixed and the protective starch layer is applied. All the other working steps are eliminated. In chemical terms, dyeing with sulfur dyes closely resembles the traditional indigo process, but sulfur dyes not only have the oxygen groups, but also sulfur-containing functional groups, known as thiols. In the first step, as with indigo, the dye molecule is reduced, causing it to dissolve in the water and change color. In the oxidation process that follows, the dye is fixed to the fiber via strong ionic bonds, and the final color develops. The sulfur groups can cross-link with each other and can also bond very strongly to the fiber via the fixing agent. This improves the strong color fastness and high abrasion resistance. In contrast to the traditional indigo dye, the jeans keep their appearance unchanged for longer. The typical used look of jeans can only be achieved with a ring effect, with which the dye does not penetrate into the fiber core. Incidentally, why only the single yarn and not the entire fabric is dyed becomes apparent when we consider the type of weaving, which gives denim fabric its characteristic look. The dyed warp threads run lengthwise, and the raw weft threads run transversely across them from side to side. Most of the colored warp threads are visible on the outside, while the white weft threads face inwards. Manufacture is much more sustainable, and the range of colors has been greatly extended, from the classic blue to stylish lilac. Advanced denim is ushering in a new era in jeans production and fashion.